Hello friends, this is the third lecture of your first module, that is on matrices. Here we will discuss some of the previous year questions from your MPSC preliminary examinations. So first question is, at what values of lambda and mu the system of equations given by x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, x plus 2y plus lambda z is equal to mu has a unique solution. So first of all, given system of equation is a non-homogeneous linear equation that is in the form of ax is equal to b. So we have represented a given system of equation in the form of ax is equal to b. Next, we have to write the augmented matrix. So augmented matrix is also written over here. Next step is to convert this augmented matrix into row echelon form by row transformations. So with the help of this a11 element, we will make this element 0. And these two elements are common to both R2 and R3, that is 1 and 2, 1 and 2. So we will apply the row transformations as R2 equal to R2 minus R1 and R3 is equal to R3 minus R2. So we have got this, that is 1 1 1 0 1 2 0 0 lambda minus 3. So from the second lecture, in second lecture we have discussed that for a unique solution, rank of matrix A must be equal to rank of augmented matrix, and which must be equal to number of variables. So here number of variables are 3, that is x, y and z. So number of variables are 3, x, y and z. So for rank of matrix to be A to be 3 as well as the augmented matrix to be 3, first possibility is lambda not equal to 3. Suppose lambda is not equal to 3, so this element will become non-zero. If it becomes non-zero, then the rank of matrix A will automatically be 3. Next is mu not equal to 0, so this element will also become non-zero. Then the rank of augmented matrix will also be 3. So this is the first possibility. Next, second possibility, lambda not equal to 3, so rank of matrix will become 3 because this element will become non-zero. Next is mu is equal to 10. Suppose mu is equal to 10, this element will become 0. But the rank of matrix is 3 and rank of augmented matrix will also remain 3 because this element is non-zero. So there are two possibilities. First one is this and second one is this. So this is a bit tricky question. Next we will switch to second question. Second question is, state whether the row vectors of a matrix represented by this row matrix are linearly dependent or independent. So first of all we will represent it in the form of Ax is equal to 0. Next we have to carry out the row transformations in order to convert this row vector into a row echelon form. So applying R2 equal to R2 plus R1, because with the help of this one we will make this second row element as 0. So with the help of this one we will make this as 0. So we have applied the row transformations as follows. Next step is R2 will be equal to R2 plus twice R3 because we have to make this element as 0. So we have to make this element as 0. Therefore we have applied the row transformations as R2 is equal to R2 plus twice R3. So R2 equal to R2 plus twice R3. So we have got this matrix. So from this 0k1 plus 1k2 plus 0k3 is equal to 0. This indicates that k2 is equal to 0. So from the third row 0k1 minus 2k2 plus k3 is equal to 0. So from this k2 is already 0, we got k3 as 0. And from the first row 1k1 plus twice k2 minus twice k3 will be equal to 0. Since k2 and k3 are already 0, k1 will also become 0. So all of the constants, that is k1, k2, k3, all are 0. Therefore the vectors are linearly independent vectors that we have seen in the second lecture. Next we will switch the third equation. If the matrix A is equal to 2, 0, 0, 1, then A to the power 100 is. So we know that A square is equal to A into A. So if we will multiply the matrix A with the matrix A itself, we have got 4, 0, 0 and 1. This 2 into 2 will 4 plus 0 into 0 is 0. So A11 element will become 4. This 2 into 0 plus 0 into 1 will become 0. We will get the A12 element. Next is 0 into 2 plus 1 into 0 will get 0. Next is 0 into 0 plus 1 into 1 will get 1. If we closely observe these two matrices A as well as A square, the only term changing here is 4. It is becoming square of these two. Remaining all the elements are as it is. Okay. So similarly we can claim that A to the power 100 will be nothing but only power of 2 will change, that is 2 to the power 100. Next all the elements will become or remain same. Next we will switch to the fourth question. Let A be the n by n matrix with rank R such that 0 is less than R less than n. Then the Ax is equal to 0 has row independent solution, sigma independent row independent solutions where row is given by dash dash. We know that if rank of matrices are such that R is less than n, then we will get n minus R independent solutions. So answer is n minus R. This is also we have discussed in the second lecture. Next question is, find for what value of k the set of equations has an infinite number of solutions. So set of equations are 2x minus 3y plus 6z minus 5t is equal to 3, y minus 4z plus t is equal to 1, 4x minus 5y plus 8z minus 90 is equal to 1. Here number of unknowns are 4, that is x, y, z as well as t. So in the first step we will represent it in the form of ax is equal to b. Next we apply the row transformation. So with the help of this element we have made this element 0 as well as this element 0 by applying the row transformations. Next step is again apply the row transformations. R3 will be equal to R3 minus R2. So we have got this. So this is your original matrix A, suppose, and this is your augmented matrix A slash B. Next we know that for an infinite number of solutions, the rank of matrix A must be equal to rank of augmented matrix AB, and which should be less than number of variables. So here number of variables are 4, that is x, y, z and t. The rank of matrix is 2 because these are two non-zero row elements, first row and second row. Next is rank of augmented matrix AB. This will become 2 only if k minus 7 will become 0. So rank of augmented matrix will become 2 only if and only if k minus 7 will become 0. That implies that k is equal to 7. So answer is for an infinite number of solutions the value of k must be 7. So here the value of k must be 7. So this was the previous year questions from your MPSC preliminary exam question papers. Okay. Thank you.